Hello everyone, welcome to our presentation on secure file transfer using IPsec concepts. I am Anvita and today I am going to explain the importance of secure file transfer and how IPsec helps in protecting data over the internet. In today's digital world, we constantly share files such as documents, images, videos, passwords, and confidential information through networks. But sending data through the internet without proper security can be very risky. There are three major risks in normal file transfer. The first risk is interception. This happens when unauthorized people or hackers capture the data while it is being transferred. If the data is not secure, attackers can easily access sensitive information. The second risk is tampering. During the transmission, attackers may modify or corrupt the data. This means the receiver may not get the original file, which can create a serious problem and reduce the trust in the communication. The third risk is exposure. Sensitive information such as personal details, passwords, or financial data may be visible to the attackers if the file is not protected. To overcome all these problems, we use secure file transfer methods like IPsec. IPsec provides confidentiality, integrity, and authentication to make communication safe and reliable.
What is IPsec? IPsec stands for the Internet Protocol Security. It is a protocol suite that operate at the network layer of the OSI model. Unlike application-based security, IPsec protect all type of traffic, making it highly efficient. Now let's understand the core features in the depth. First one is the confidentiality. This is achieved through the encryption algorithm such as AES or DES process. The plain text encrypted into the ciphertext. Only the receiver with the correct key can decrypt it. This prevents unauthorized user from understanding the data. The second one is integrity. It ensures that data is not altered during the transmission, implemented using the hashing algorithm like SH. A hash value is generated before sending, recomputed at the receiver side, and if both matches, data is intact. Even a single bit change will result in a mismatch. A third one is the authentication. It confirms the identity of the sender and the receiver. It achieved through 2 point pre-shared keys and the digital signature. Prevent the impersonation attack. There are two types in the modes of the IP section. One is a transport mode and another is a tunnel mode. First one is transport mode is encrypt only the payload and faster and efficient. Tunnel mode is encrypt entire packet, provide higher security and used in the VPNs. So IPsec ensure end-to-end security at the network level.
The system is designed to provide a secure file transferring using IPsec-like concepts such as encryption, integrity verification, and key-based authentication. At the sender side, the original file is first processed to generate a hash value using the SHA-256 algorithm. This hash acts as a unique fingerprint of the data and help in detecting any modification during the transmission. After generating the hash, the file is encrypted using the AES encryption. This ensures that the data become unreadable to any unauthorized user, thus maintaining the confidentiality. The encrypted file along with the generated hash is then transmitted over the network. Since the data is encrypted, even if an attacker intercepts it, they cannot understand the content. At the receiver side, the encrypted file is decrypted using the same secret key to retrieve the original data. Once the file is decrypted, a new hash value is generated for the received data. The new hash is then compared with the original hash and sent by the sender. If both hash value matches, it confirms that data has not been altered and maintained its integrity. If the hash value do not match, it indicates that data has been tampered with during transmission. Thus, this system ensures secure communication by providing the confidentiality through encryption, integrity to hashing, and authentication using the shared key.
In this, we implemented a simple model based on IPsec concepts. First, the file to be transferred is taken as input. The data is then encrypted, which converts it into an unreadable format. After that, a hash value is generated from the original data. This acts as a reference to verify the data later. The encrypted data, along with the hash value, is sent through the network. At the receiver side, the encrypted data is converted back into its original form using decryption. Then new hash value is generated and compared with the original one. If both values are same, it confirms that the data has not been altered during transmission. In the output, we can observe that the data is first converted into an encrypted format before transmission. After receiving the data is successfully decrypted back to its original form. The system also performs hash comparison to verify the integrity of the data. If the data remains unchanged, the process is completely completed successfully. If there is any difference, it indicates that the data has been modified during transmission. To conclude, this demonstrates how secure file transfer can be achieved using IPsec concepts. The system ensures the data remains protected while being transmitted over a network. It also verifies that the data received is exactly the same as the data sent. This approach can be applied in real world scenarios where secure communication is required over the internet. Thank you.